Hi, Earth Science students. Video here for you today to go over the Unit 6 study guide. This is information you need for your Unit 6 Lesson 11 test. Is our last lesson of new material before the end of the trimester and the final exam. So I'll just go over the major topics and kind of point you in the direction of what you'll need to know. The first thing would be the atmospheric conditions that lead to precipitation. So cold fronts usually bring precipitation with them. A cold front is when cold air displaces warm air, and that warm air rises and causes things like thunderstorms and heavy rains. These types of storms are usually short-lived, so they only last for maybe a few minutes to a few hours at the most. Once these cold fronts move in, they bring cooler temperatures. So kind of that mixing of the cool air with the hot air that's already in place causes these precipitation and storm events, but the cold front brings in cooler temperatures. So cold front, cooler temperatures, and precipitation. What's the difference between a storm watch and a storm warning? You need to know that. A storm watch is less severe. It's when you should begin to prepare. It tells you that the conditions in the atmosphere are favorable for that type of event to happen. So it might tell you a thunderstorm watch says that, yeah, maybe later today a thunderstorm could take place. A warning is when it is happening. So it means that they've either spotted it or they know, a meteorologist knows that the conditions in the atmosphere are causing that type of event to take place. So a warning is when you want to take shelter, is when you want to start your action plan for whatever the storm is. On this unit test, you'll also need to know the different types of fronts. So I've got the map over here to show you that. A cold front is shown here that's indicated by these triangles in blue. A warm front are these kind of semicircles shown in red. A stationary front is when we have two fronts that are opposing and kind of meeting each other. So we've got the semicircles and the triangles kind of hitting each other. And this is indication of a stationary front. And here we have an occluded front. So we've got the mixes of semicircles and triangles and kind of the blending of the colors as well. So that red and the blue come together and we have a purple indication of that occluded front. So those are the four different types of fronts that we talked about. The next would be the instruments of weather data. So how do we gather data about the weather, gather data about the atmosphere? We use these different tools. First is a barometer. Barometers measure the pressure. So they measure it usually in millimeters of mercury. It's going to tell us about the pressure in the atmosphere. So how dense the molecules of the atmosphere are and how they're moving around. Thermometers just measure air temperature. Aerovanes measure wind speed and also wind direction. A hygrometer measures humidity, so what the moisture levels are in the air. A radiosonde is also called a weather balloon, and it measures the conditions in the high levels of the atmosphere. So it measures things further up than at the ground level. What kind of clouds indicate precipitation? Those cumulonimbus clouds indicate conditions that may be right for severe weather, such as thunderstorms and tornadoes. So when we see these severe weather conditions, tornadoes and thunderstorms, there's usually an uplift that takes place. So the air will warm at the surface of the ground. Our ground is usually hotter than the air above it. That air warms up and it rises, it lifts up because it becomes less dense. And when it does that, it cools down. So it creates those circulation patterns that we talked about earlier in this unit and in Unit 5. When we get these kind of severe mixing of hot and cold, that's when we can have events like thunderstorms and tornadoes take place. The clouds will usually, when we see precipitation coming, they're going to be low-level clouds, so low in the atmosphere, and they're usually dark in color, and they look sort of like a blanket kind of covering the sky. Today in class, we talked about urban heating patterns. So dark surfaces absorb lots of heat. They have a low albedo. Albedo tells us about how much heat is reflected from a surface. So things like snow and ice would have high albedos. They reflect a lot of light. Light bounces off. That's why it looks really bright. Maybe if you go skiing or snowboarding at a mountain, you probably have to wear sunglasses or goggles because all that light is being reflected because it has a low albedo. But surfaces like pavement or blacktop or even brick buildings, they absorb a lot of heat. So in cities, we get these urban heating patterns. So downtown areas tend to be hotter. We're looking over here on the y-axis at temperature. These urban heating areas tend to be hotter because they have the lowest albedo, and so they're warmer. Areas that are rural, that don't have as many paved surfaces, that have lots of trees and grasses, they reflect a lot of the light back, and so they tend to be cooler. So even on the same day, if you look at the area around where you live, if you live in a more rural or suburban area, your temperatures will be lower than if you live in a downtown area because there are not as many surfaces absorbing heat. Okay, finally, we have weather patterns. Weather patterns over short time are just called weather. But when we look at long-term patterns and long-term averages, we're discussing the climate. And one example that we talked about was Seattle. So in Seattle, the climate tends to be rainy. There is a lot of precipitation throughout the year if you live in Seattle, but that doesn't mean that you don't have sunny days. So the short-term pattern, what it looks like today, could be very warm. It could be very sunny. It might be snowy. It can be rainy. Those are your the short terms, and those are weather. But when we talk about climate, we're talking about more about the averages that happen over months or even years. Finally, some terms related to wind movement and wind direction. So orthographic uplift is a movement of air sort of up over some obstacle. And in this case, we have a mountain here. So imagine if we're looking at Washington State, we have the Cascade Mountains, sort of in the middle of the state. On the side of the mountain where the wind hits, so wind comes off the Pacific Ocean, comes down from the North Pole, and it hits these mountains, hits those Cascade Mountains. It can drop off any precipitation that it is carrying with it. So we call that the windward side of the mountain, and we tend to have more rain on that side, or more precipitation on that side. Once that precipitation is dropped off, the air continues to move across over the mountain, but there's not as much moisture left with it. And so that's why the eastern side of Washington State tends to be a drier climate, because it has these mountains that sort of capture or prevent moisture from being carried to the other side. Orthographic uplift is just the movement of air kind of up over an obstacle. So this upward movement is called orthographic uplift. The side of the mountain where the wind hits is called the windward side. The side of the mountain where the wind or the clouds move after they've dropped off that precipitation is called the leeward side. It tends to be the drier side. Those are the main ideas that you need for the Unit 6 exam. Just as a reminder, we have final exam prep starting tomorrow during office hours. The unit test is due by the end of the day on Wednesday, and the semester test is due by the end of the day on Friday, March 6th. Please visit me if you need help during office hours. It is a big exam, worth a lot of points, and I'm here to help you study and prepare for that. Look out for a video coming up later this week so that you can review for final exam information. Keep up the great work.